All right, so here we're going to talk about how to do L3. It was really math heavy. A lot of us struggled with it. A lot of us struggled with it on the quiz. And I guarantee you that there's going to be parts of the test that are very, very similar to this. So let's talk about how to do it. Here's the assignment page when I am in Canvas under modules. You can go down here. If you don't have the worksheet, you can download it. There's a couple other things that we did here, that dimensional analysis handout, which I'm going to go over in another video. But go ahead, click on lesson 3 worksheet, and we are going to pull it up here. So anyway, we're trying to figure out basically how much sea levels would rise if all of the ice in Greenland melted. So the way that we would start doing this is we need to figure out what the volume of the ice on Greenland is. And to do that, we need to find the area of Greenland. So we're starting by figuring out what the area of this shape is. And remember, area is length times width. So if we were to figure out the area of this square, 1,000 times 1,100, that is 1,100,000. So that's the area of just this square right here. To find the area of a triangle, you do length times width, but you divide by 2 because it's half of a rectangle. So whatever half of 1,100,000 is, and which is what is that number? 550,000. We're going to add those together, and we have 1,650,000 square kilometers. So that's what the area of Greenland is. And again, we figured that out because we took the length times width of one part of it, the length times width divided by 2 of the other part, and then added those two together. So our current area, again, is 1,650,000. But since volume is length times width times height, we need to multiply that number by a height value, which they give us right up here. The ice sheet averages 1.5 kilometers tall on top of Greenland. So we take that number, multiply by 1.5, and we get 2,475,000 kilometers cubed. So the total volume for Greenland is that 2,475,000 kilometers cubed. And if you remember from our last assignment, the L2 assignment, and actually by now you should sound familiar from even the stuff we did for L8, way ahead. The sea level rise is equal to the volume of ice divided by the area of the container. And the container in this case is Earth's ocean. So you would take the 2,475,000, divide it by Earth's area, the ocean's area. And if we do that, we should get, I believe it's 0.0068, but let me do it on here. Yep, 0.0068 kilometers. You can give that to me as 0.008 kilometers, or you could convert that into meters and give me 6.8 meters. Same thing, totally, I'll take both responses. So, basically we just walk through how to figure out 1 and 2. How much would Earth's sea level rise if all of Greenland's ice melted in the ocean? 6.8 meters. And then 3 says, what if only 25% of Greenland's ice melted into the ocean? A lot of people got stuck on this one, and it really is as simple as it looked. If 100% of the ice melted was 6.8 meters, 25% of that is 1.7 meters. So if only 25% of the ice melted, then only 25% of that sea level rise is going to happen, if that makes sense. And you can calculate that by taking that 6.8 and either multiplying it by 0.25 or dividing it by 4. Both of those work. Solutions or ideas to reduce melt, those are just some ideas. What ideas do you have at this point that we could do to try to slow down the polar ice caps melting? There's no wrong answer as long as it makes sense, and the goal of the idea is to stop melting from happening. So that's how you do this one. I'm sorry that there's not like a feature on here for me to kind of draw and follow along with you. In future videos, I'll put a calculator on here, and hopefully that will help us out. That's how you do lesson 3, the worst case scenario. If you have questions, you can email me, let me know, and we'll figure it out together. Good job.